Hi, okay, this video is going to be for subtracting mixed numbers. So I'm going to show it kind of with models as well as doing just the algorithm when we are subtracting these. Now we know that when we are subtracting that we need to keep in mind that we need to have common denominators. And in order to find our common denominators that we multiply by a specially chosen one, okay? So I'm reading this problem and it says Bart used a ruler to measure how much snow fell while he was outside. Okay, so they're measuring and snow is falling outside. There were 5 2/3 inches of snow when he went outside and 6 5/12 inches of snow when he went inside. How much snow fell while Bart was outside? Sorry, I was yawning. Okay, how much snow fell while Bart was outside? Okay, well, I'm going to mark some information like when he went outside. So, like, basically to start with, there was 5 2/3 inches. When he went inside, there was 6 5/12 inches. And it wants us to figure out how much snow fell while Bart was outside. Okay. So when he first went outside, again, 5 2/3 inches. And it seems like more snow fell. I know more snow fell because it went from 5 to 6 for a whole number. So to figure out how much went from the beginning to the end, I'll have to subtract these two numbers. So I'm going to set that up. I'm going to pause so I can write it. Okay, so I'm just showing you that I'm choosing to write it this way because I know that it's easier for me to just multiply across when I do it this way. However, I do want to draw some models of this as well. So I'm going to quickly pause to draw my 6 wholes and then my 5/12. Okay, I'm going to unpause here. So for this one, I've drawn my 6 and 5/12 over here. So I could color in this whole thing, this whole thing, this whole thing. So that's going to give me a total of 6. And then I would color in 5/12. I kind of don't want to do that with this color. I'm going to do it with this one so I can kind of see. 1, 2, 3, 4, 5. Okay, so it's a little less than half. And then I'm going to pause and draw my 5 2/3. So again, for this one, I've drawn my 5 holes. So 1, 2, 3, 4, 5, and then I've cut it up into thirds for this one, which I know I'm going to have to fix in a little bit because I need my denominators to be the same. Okay, so notice that I've still drawn my two models. I will find the difference between those, right? Because it's asking me how much snow fell while Bert was outside, which tells me that, again, I'm going to find the difference, okay? When I'm finding the difference, again, I still need to find the common denominator. For 12, I noticed that I can use 3 to get to 12. If I skip count, I could do 3, 6, 9, 12. So I'm going to go ahead and set that up. So I've set that up, and I'm noticing that for twelfths, because I know that 3 times 4 equals 12, I don't necessarily need to change this, so I could just model that by writing 1 over 1 to get the same fraction. Now, something that I've realized is I forgot to do my whole number, right? Well, I know 5 times 1, my carefully chosen 1, is going to be 5. So I'm going to fix that really quick. Now I'm kind of just solving as normal. So 6 times 1 will also be 6. And then I can solve for my numerators. Well, 5 times 1 equals 5. 12 times 1 equals 12. Yep, that's my common denominator. It should be 12. All right, and then for my numerator down here, it says 2 times 4 is 8. Well, if I'm seeing that I'm now making my thirds into twelfths, I've cut each of these thirds into fourths. So I'm going to go ahead and model that over here. One moment. So I'm going to cut this up into fourths. 1, 2, 3. 1, 2, 3. 1, 2, 3. So now if I even count very carefully, I can see that I colored in 1, 2, 3, 4, 5, 6, 7, 8, all the way up to this line, which matches what I wrote over here. Now again, I'm finding the difference between these. Now you're going to see that I run into an issue. 5 minus 8, I can't do. So where can I get more of my 12ths, right? Well, what you're going to basically do is regroup from over here, your 6, and get your 12ths from over there. So in base 10, you do 10, right? Because that's what the units are made of. But my whole has 12. So I'm going to cut this up and I'm going to be left with 5. So, and then I'm going to basically cut this into 12ths as well. So I'm going to do 1, 2, and I'm going to do that 12 times. I'm not going to do it perfectly right here over here. So if I have 12 twelfths in this plus my 5 twelfths, how many twelfths do I now have? Well, it's not 15. 12 and 5 make 17. Oh, okay, 17 minus 8 I can subtract that, okay? So again, I'm finding the difference between these two values, okay? So I'm looking at these and I'm finding the difference between 17 and 8, which I know is going to be 9. So I'm going to write 9. I'm not changing how many parts are in my whole. It is still 12. And then finally, I'm subtracting my whole numbers, and that's going to be 5 minus 5, which is 0. So my answer is 9 twelfths. Again, that's going to take some practice breaking apart your whole number into your fractional parts. That is a-okay. So go ahead and keep practicing that as we are learning to subtract our mixed numbers. Make sure that you have paused throughout this video to take notes. If you need to pause here and take notes, please do so.